In today's lecture, we will be discussing rate of change. The best way to do is with the help of few numericals. So let's begin with the first problem. We need to find out the rate of change of volume of a sphere when the radius is 6 inch and is increasing at the rate of 0.2 inches per second. The meaning of this problem is, assuming that the volume of the sphere is given by V equals to 4/3 pi r cubed, where r represents the radius of the sphere. So here we have been asked to find out the rate of change of volume. The rate of change means the change in volume with respect to time. So this is referred to as the rate of change of volume. So whenever our independent variable is t, or simply said, when we're differentiating with respect to the time t, that is when we call it rate of change. So the rate of change of volume, we need to find it out. So here it's also provided that the rate of change of radius, which will be derivative of r with respect to time t, so this is given as 0.2 inches per second. So that means the radius is increasing at this particular rate. Every 1 second it's increasing by 0.2 inches. So let's find out the rate of change of volume. So we have dv dt. So this will be equals to ddt of volume. So our volume is 4/3 of pi r cubed. 4/3 of pi. So this is a constant. So we have taken it out of the derivative. So all we need to do is find the rate of change of r cubed. Now in order to find out the value of the rate of change of r cubed, all we need to do is use the power rule. So if we assume that r is equivalent to t, then in that case we have ddt of t cubed, which should give us 3t squared. So we will have 3, but instead of t, we will write r squared. Then again, r is not t, so we need to multiply it to the derivative of r with respect to time t. Now, we find out the rate of change of volume. Now when the radius r is 6 inch, then dv dt, we need to find out the rate of change of volume. So this will be given by 4/3 pi times 3 times r squared. So r will be 6 squared times dr over dt, which is 0.2 inches per second. So here 3 and 3 goes away. So we have 6 squared will be 36. 36 times 4 times 0.2. So this gives us the value 28.8 pi inch cubed. That will be the cubic inch per second. So this is the rate of change of volume, 28.8 pi cubic inch per second. So let's try out another problem. Problem number 2. So it's given that two friends are beginning to walk at the same trailhead. Let's say they start from the same trailhead. One heads towards north. So this is the northern side. Let's call it from the origin O at 4 meters per hour. And the other heads east at 6 meters per hour. So let's say this is our eastern direction. So this is 6 meters per hour, and the other one is going at the rate of 4 meters per hour. The question is, 2 hours later, what will be the pace at which the distance is changing? So actually this is the distance, let's call it s. So we need to find out the rate of change of the distance s, which is changing after 2 hours. So let's find it out. Now here from figure, we can use the Pythagoras theorem. We can say that ne squared, which is the distance of separation between this particular point and this point at any given instant of time, will be equals to OE squared plus ON squared. So let's say that this value is x, any particular instant of time, and this ON value is y. So that means we have s squared is equals to x squared plus y squared. So let this be equation number 1. Now what we'll do, we'll take the derivative of both sides with respect to time t. So derivative of s squared, use the power rule to give us 2s, but s has to be multiplied. Then we need to find out the derivative with respect to time t of s and multiply it to 2s using the chain rule. Similarly, we have to use the chain rule. So this will give us 2x times dx over dt, or the rate of change of x, plus 2y times rate of change of y. So this will become our equation number 2. So here we are provided that dx over dt, which is the rate of change of x, which is one of the friend which is moving towards the eastern direction with a value of 6 meters per hour, and dy over dt, which is the rate of change of direction y, or you can say that the one of the friend is going towards the northern direction with 4 miles per hour. This would mean that after 2 hours, x will be equals to, so dx over dt means what? It is moving at the rate of 6 meters per hour. That means in 1 mile, one of the friend has covered 6 meters. So after 2 hours, it will be covering 6 plus 6, which will be equals to 12 meters. Similarly for y, who is moving at the rate of 4 meters per hour. So after 2 hours, the person will be moving with a speed of 4 plus 4, which is equals to 8 meters. Right. So we have the value of x and y here. Now we also need to find out the value of s. So that means s squared, which is equals to 12 squared plus 8 squared. So 12 squared is 144 and 8 squared is 64. So this will be 208. So s will be, after 2 hours, the distance between the two friends will be square root of 208 meters. Fine. Now we will substitute all this value into equation number 2. So that means now equation number 2 follows. We have, so here we can see that we can factor out 2 from both the sides. So we have ds over dt, that means the rate of change of distance of separation s will be given by x over s times dx over dt plus y over s times dy over dt. So we can substitute all the values. So x is 12 and s is square root of 208. So our x value is 12 meters divided by s, which is square root of 208 times rate of change of x, which will be 6, plus y value is 8 divided by square root of 208 multiplied to dy over dt. So that is, so when we plug this value into a calculator, this is going to give us approximately 7.21 meters per hour. So this is the pace at which the distance is changing. Let's move on to the next problem. Problem number 3. So we have a 3 feet ladder that is slipping down a wall. Assuming that the ladder is 5 feet from the wall at time t equals to 0 and moving away from it with a constant speed of 3 feet per second, we need to find the top of the ladder's velocity at t equals to 1 second. Let's try to illustrate this particular problem. So we have the wall, which is denoted by the y-axis, and we have the horizontal axis x. Let us consider a ladder which is 10 feet long. So here it is given that the ladder is 5 feet from the wall at time t equals to 0. So this is 5 feet at t equals to 0. However, since the ladder is slipping, that means the top of the ladder is going downwards while the bottom of the ladder is slipping in the horizontal direction. So that means at any given moment of time, let's say the distance of the top of the ladder from the origin O, this is y, and the bottom of the ladder from the origin is x. Then at any given moment of time, or we can say at any time t, we can use the Pythagoras theorem. We can say that x squared plus y squared is equals to the hypotenuse here. So hypotenuse is 10, so this will be 100. Let's call it equation number 1. Also is given that at time t equals to 0, our x is 5 feet, and it is, this is the other information, that it's slipping at the rate of dx over dt is equals to 3 feet per second. That means every second it is slipping with a distance of 3 feet. So that means after 1 second, our new value of x will be, so initially it was 5 feet plus it is moved by a distance of another 3 feet. So that means this is equals to 8 feet. So this is after 1 second. Now consider equation number 1. What we need to find out is the top of the letter's velocity. That means we need to find out dy over dt. To do that, let's take equation number 1 and take the derivative on both sides with respect to time t. So that will give us 2x times dx over dt. We have used the chain rule here. Similarly, we have 2y times dy over dt. We have also used the chain rule, which will be equals to 0. So we need to find out dy over dt. So let's solve for dy over dt. So this will be equals to negative x over y times dx over dt. And we need to find this value after t equals to 1 second. So here we have already found out the value. This is provided dx over dt, which is 3 feet per second. We have the value of x, which is 8 feet. We need to find out the value of y. So we'll again use equation number 1. So from 1, the value of y will be equals to 100 minus x squared. So the value of x is 8 feet. So 8 squared will be 64. So 100 minus 64 is 36 and square root of 36 will be 6. So that means after t equals to 1 second. So after 1 second is elapsed, this height will be about 6 feet. So let's substitute all this value into our equation. So x is negative 8. We have y, which is 6 multiplied to dx over dt. So this is given as 3. So this will give us, so 8 times 3 is 24. 24 divided by 6 is 4. So this is negative 4 feet per second. So that means the top of the ladder is slipping downwards with a value of 4 feet per second, or your negative sign indicates that this is slipping downwards. Let's move on to the next problem. Problem number 4. So here we have water pouring into a rectangular tank with rectangular base of 4 feet by 9 feet. So let's try to sketch the problem. So we have a tank with a rectangular base. So let's consider the length to be 9 feet and this is 4 feet wide. And this particular tank has a height of h. This is the height. So that means the volume of the tank, so that will be equals to 9 times 4 times h, or we have 36h. So this is the volume, equation number 1. Now there's water, we have a water that's flowing into this particular tank. So let's say this is flowing into the tank and is flowing with a rate of 2 cubic feet per minute. So that means the rate of change of volume in the tank is given as, we have positives because it's filling up the tank. It's 2 cubic feet per minute. Equation number 2. Now the question is, how fast is the water level rising? So let's begin by taking equation number 1 and we take the time derivative on both sides. So we have dv over dt. So this will be equals to 36 times dh over dt. Fine. Now it's given that dv over dt is 2. So we have 2 equals to 36 times dh over dt, or solving for dh over dt. So this will be 2 over 36, which is equals to 1 over 18 feet per minute. Let's go to the next problem. Problem number 5. So it's given that water now fills a conical tank with a radius of 4 feet and a height of 10 feet at a pace of 3 cubic feet per minute. So here we have a conical tank. So this conical tank has a radius of 4 feet. Let's consider this is to be the base level. So the height of this conical tank is given as 10 feet. We have, let's say, a hose pipe and this is filling the tank with water. Now the rate at which this is filling the water is given as 3 cubic feet per minute. So if we consider the volume of the tank as V, is the same as saying that the rate of change of volume means the amount by which water is filling the tank. So this is given as 3 cubic feet per minute. What we need to find out is how quickly does the water level rise from a level of 1 foot to a level of 5 feet. So let's say this level is our 1 foot, and we have to check out how quickly does it rise from 1 feet to 5 feet. So let's do this problem. Now we know that the volume of the tank, the volume of the water tank V is given by 1/3 the volume of a cone, which is pi r squared h. Now here we have two parameters, the radius as well as height. So what we'll try to do, we'll try to write the radius in terms of the height. So to do that, we'll consider the side view of the tank. So here we have the tank, which is having a radius of 4 feet and the height of 10 feet from the base level. We will consider another level of the cone, which is at a height of h from the base and has a radius of r. Now using the properties of similar triangle, we can say that the radius r divided by the radius of the entire cone is equals to h divided by 10. So r will be equals to 4/10 times h, or simply r is equals to 2/5 of the height. So this is the relationship between the radius and the height of the cone. Now we will substitute the value of r into our volume of the tank. So that means our volume of the tank will then become, so equation number 1 gives, so the volume will be equals to 1/3 times pi, so r is 2/5 h whole squared times h. So 2 squared will be 4, so we have 4 pi divided by 5 square is 25, 25 times 3 will be 75 times h cube. So this is the volume of the tank with respect to the parameter h, which is the height of the cone. Now let's take the derivative on both sides with respect to time. So the time derivative of the volume, dv over dt, so this will be equals to 4 pi over 75 multiplies to the rate of change of height cube. Now here we need to use the power rule and the chain rule to find the derivative of h cube. So we have 4 pi over 75 multiplied to 3h squared times dh over dt. Now in the question itself, it was given that the rate of change of volume is 3 cubic feet per minute. So we have 3 here, so that means this 3 and this 3 cancels out, and dh over dt then will be 75 over 4 pi h squared. So this is the expression for the change in height. Now according to the question, what we need to find out here is at h is equals to 1 foot, when our height is 1 foot, then the rate of change of height, so that means water is filling up with the rate of, we have 75 divided by 4 pi, and this gives us approximately, this is 1 squared, 5.97 feet per minute. And at h is equals to 4 feet, when the height is 4 feet, that means when the water level is increased to 4 feet, then we have dh over dt, so this will be equals to 75 divided by 4 pi h squared, so this is 4 squared, and this gives us the value 0.37 feet per minute. Now here we can see there's a huge difference in the value here. So this is approximately 6 feet per minute. At a height of 1 foot from the base of the tank, it will fill up at a very faster rate of 6 feet per minute because it's narrower near the base. And as the height increases, what we see that the radius of the cone increases. So that means it's the rate of filling up of the water inside the tank is going to increase at a much slower rate. So this was all about rate of change. So I hope with the help of these 5 problems, we were able to gather some idea about how to find the different rate of changes. So see you in the next lecture. Thank you.